Hello, I'm your host, Mr. Fixit from ES Repair. In this video, I will discuss the purpose of BIOS and how it has evolved to the new UEFI. BIOS is the acronym for Basic Input-Output System that has been used in PCs since 1975. Its purpose is to provide a hardware abstraction layer so that software can access hardware directly, such as the keyboard, display, disk drives, and so on. It initializes and tests the system components, known as the power on self-test or POST, then loads and hands over the controls to the bootloader to start up the operating system. The BIOS varies between manufacturers and is designed around the motherboard's chipset, which is a set of components known as the North and South Bridge that manages the data flow between the processor, the memory, and the peripherals. The BIOS is firmware stored on flash memory known as Electrically Erasable Programmable Memory, or EEPROM. The BIOS chip can be found near a set of jumper pins that is used to reset BIOS to default settings and clear BIOS passwords. The jumper pin is used in the event BIOS fails to boot due to a change in the system. Some motherboards will have the BIOS chip labeled as you see here. The BIOS setup utility allows the user to configure hardware components like operating modes, adjust frequencies for overclocking, how a device is detected by the operating system, setting the clock, enable or disable devices and features, set the boot device, and set various passwords to prevent malicious users from changing the system configuration or booting up the PC. Another function of BIOS is the ability to update the CPU's microcode. All CPUs use microcode that instructs the processor how to operate. Most of the CPU's coding is hardwired, but if there is a problem with the coding, an updated microcode can be used to correct anomalies in the CPU code. For example, Intel had an issue with their Pentium P5 processors back in 1994 that had the floating point division bug, which returned an incorrect result during math division, affecting the 3rd to the 15th digit. The second generation of the Pentium P5s had a power management bug. When the chipset invokes the processor's sleep function, the system would hang up. And most recently was a Meltdown and Spectre bug, which allowed rogue processes to read all the memory addresses regardless of the privileges. Now, although a BIOS update is very rare, when a bug is found in the CPU's microcode, manufacturers can provide an update to BIOS so when the PC starts up, the BIOS will load the updated microcode to the CPU during post. The PC manufacturer can also update BIOS to add new features and improve performance. However, if a BIOS update fails, you have a useless PC, unless you made a backup copy of BIOS stored on the hard drive or a flash drive. Some motherboards like this one have a BIOS backup, often referred to as dual BIOS. In the event BIOS becomes corrupted, preventing the PC from booting up, the backup can be used to restore BIOS to working order. Viruses have also been known to attack BIOS, making a PC useless by deleting the contents of BIOS. With hard drives ever increasing in capacity, BIOS cannot access drives using the GUID partition table or GPT format. It can only access drives using the master boot record format, which is limited to a maximum of 4 partitions per drive at 2 terabytes per partition. The BIOS was replaced with the Unified Extensible Firmware Interface, or UEFI. It was first developed by Intel in 1998, called the Intel Boot Initiative, and was later renamed Extensible Firmware Interface. In 2005, the Unified EFI Forum took over the development of the UEFI specifications. PCs manufactured since 2012 now use the UEFI platform. UEFI has several advantages over the legacy BIOS. PCs can now boot from drive partitions larger than 2 terabytes using the GPT format. It supports remote diagnostics and repair of the computer, even if there is no operating system installed. In the pre-boot mode, legacy BIOS was limited to 16-bit mode, which applications could only access up to 1 megabyte of system memory. UEFI allows 32 or a 64-bit mode to give pre-boot applications access to all system memory. UEFI can run pre-boot applications such as Windows Boot Manager, UEFI Shell, Recovery Manager, Diagnostics, Disk Utilities, and more, which can be installed independently from the system manufacturer. UEFI contains hardware drivers needed for pre-boot applications to access the CPU, memory, display, hard drive, and more. The VGA protocol was replaced with the Graphics Output Protocol to reduce hardware dependencies. This allows pre-boot applications to access the GPU regardless of the hardware. Unlike the legacy BIOS, UEFI doesn't rely on the hard drive's boot sector to load the operating system. The UEFI has the boot manager built into its firmware. This is a plus, since viruses have been known to infect the hard drive's boot sector. Operating systems can be automatically detected by the UEFI firmware. The UEFI also includes the Compatibility Support Module, or CSM, which allows the legacy operating system and hardware to function. This mode lets the UEFI behave as legacy BIOS, allowing hardware and software not compatible with UEFI to function properly. Secure Boot prevents the loading of drivers or operating system loaders that are not signed with an acceptable digital signature. However, the details of how these drivers are to be signed are not specified. Secure Boot was designed to prevent viruses from infecting the boot process. PCs manufactured since the fall of 2012 support Secure Boot. Although the UEFI sounds better than a legacy BIOS, there are some drawbacks. The UEFI requires the firmware and the OS loader to be size matched. For example, if the UEFI is a 64-bit firmware, then the operating system must also be a 64-bit. Therefore, you cannot run a 32-bit operating system on a 64-bit UEFI platform, and vice versa. It was criticized that UEFI was an attempt to remove the user's ability to fully control the PC, and it doesn't solve BIOS's problem of requiring 2 different drivers, one from the firmware and the other from the OS from most hardware. Now, Secure Boot did come under fire when Microsoft announced in 2011 that computers certified to run its Windows 8 operating system had to be shipped with Secure Boot enabled using Microsoft's private key. Critics like the Free Software Foundation claimed that Microsoft was using Secure Boot to lock in Windows OS and prevent the end user from installing an alternative operating system. Microsoft's response was stating that Intel-based PCs must allow Secure Boot to enter custom mode or be disabled, but not on systems that use the ARM architecture. Windows 10 allows the OEM to decide whether or not Secure Boot can be managed by the end user on the x86 systems. When Windows 8 was released in late 2012, it was discovered that Lenovo PCs could only run Windows 8 or Red Hat Linux regardless of the UEFI settings. Toshiba PCs that had Secure Boot enabled were missing certificates required for proper operation. Now, Intel has announced that they will be removing the compatibility support module by 2020 to eliminate components with no UEFI support. By ensuring that drivers, peripherals, and utilities work without CSM. Intel wants to improve the user experience of UEFI Secure Boot, ensuring that the industry validates their tools with Secure Boot on, so that end users don't need to enable the CSM to resolve recovery issues. All manufactured PCs that came with Windows 8 and or Windows 10 pre-installed use the UEFI platform. Some manufacturers still call the UEFI BIOS to not confuse the end user, but they both have the same purpose. Well, I am your host, Mr. Fix-It. Thank you for watching.